Alright, so at the end we should understand the basics of SWI network, the blockchain, and set up a SWI wallet to interact with the network. Very easy, and interact mint and NFT on SWI blockchain. Very good. So what's a SWI? So obviously this is your high performance layer one. That means it doesn't depend on any chain. It is used from ground right up and focus on speed and scalability. Obviously. And centered around assets and objects, and it uses proof programming language. Very important. These three stuffs are you have to pay attention. So the first one I just telling you that this is an L1, and number two is saying it is centric and object-centric, and number three is saying programming language used to write a smart contract on the SWI network or blockchain. It's called So how is SWI different from objects? How is SWI different? Object-oriented model. Okay, so this object-oriented model is talking about not far different from the object-oriented model you see in JavaScript. So in JavaScript, they'll tell you everything is an object, right? Same thing works here. Every asset on switches is an object, so much so that everything you can find on your chain has an object ID. Your wallets have an object ID, right? So we can look at that much later. But then now each object has a unique ID and can store data or modify. And this model is different from account-based blockchain. So account-based blockchain is talking about a custodian account, right? SWI doesn't operate that way. It's not custodian, such that assets are managed by a smart contract. But then in SWI, instead of an asset to be managed by a smart contract, the asset is managed or it's being bound to an address. Alright? For instance, in EVM, you have a smart contract hold funds, you have a smart contract handle funds, but then it's different here. And let me give you something, a display that shows that. So I'm going to make a rough sketch here. Share that. So let's look for assets, an icon that can represent assets. Let's say coin. That is a coin. And let's look for an icon that represents smart contracts. Yep. Smart contract, right? So in EVM, this is how it works. Now, this is an asset. Let's look for an icon that represents an address. Address, better still, an account. This is an account, right? This is an account. This is somebody on chain, right? Let's say this is a chain. All of this thing represents a chain. This is a chain. So now in EVM, this is how it operates. So in EVM, you have this a smart contract that is like transparent, it's self-executable, nobody have an superior rights over the execution of this smart contract. So it executes by itself. No, everybody see the logic of the code and everything. It's transparent, and you cannot how will I say it, bend the smart contract implementation based on your personal preference. That's why it's smart contract. So it is not like a guy that is written in a manner that it benefits a particular person, but then it executes whatever it executes in such a way that it is decentralized. There's no decentralized owner to it. But then the smart contract in EVM chain does this. So this is an asset. Let's say this is some SWI. It is tied to the smart contract. But then the smart contract will point that asset to this user. Point it to this user. That's what happens here. But in SWI, we don't do that. So now this gives chances for stuff like re-entrance attack. Guard of re-entrance attack such that the execution of the smart contract doesn't come to finality, but then an attacker will attack that, will send a malware or will send a malicious software to that particular smart contract. In course of the execution, they can actually make that smart contract make a call to another smart contract. So that re-entrancy issue will iterate over time. That's how they can have access, right? Because in course of execution, there is a state, right? So that state will house some sort of assets. But then you see, we don't handle things that way. So if you are writing SWI move programming language, smart contract, make sure that whatever asset you are having has to be transferred away from the smart contract, or it will be, what's it called? It will be bond if it's an NFT, or yes, or it will be structured, right? If it is just, let's say, a storable struct. So yeah, so that's how it works. But this is EVM. Now in SWI network, this is how it works. So it's the asset is directly owned by the owner. It points to the address. It doesn't go this way. So what the smart contract does is, the smart contract is just that guy that makes sure that the execution that happens here is whatever execution that happens here, the execution that happens here is solved, or how will I put it? The execution that happens here is decentralized. So it doesn't have anything to do with saving the assets. That's how it works. Now, so now this will lead us to talking about I'm going to write some code now which will thoroughly explain the object-centric asset feature properties and asset-centric property of features. So let's look at something. So now, before I do that, I want you to picture this. In EVM, you have your assets to be managed by a smart contract, right? But then in SWI, it is not that way. It is this way. So what the smart contract does is, it does every logic that you're writing, every computation that you're writing, and at the end of each computation, that particular asset that is being created will be moved away from the smart contract to the owner. So the smart contract is just like a guy that makes sure that, okay, fine, this logic is being implemented, this check is being looked at, but then it doesn't hold your asset. But in EVM, the asset is held by the smart contract. Alright? Now, the object-centric nature here is every person, including the assets on chain, has an ID, has an entity for itself. It can be considered to be an object, even to your SWI. Right? The smart contract itself has an object ID. You're going to see that if you publish a smart contract, your address to have an object ID, and they are actually represented in form of your address, your normal address in your wallet. So now let's look at a simple smart contract. So now first, what I'm going to do here is I'm going to write a contract that means NFT, right? So let's say we want to create an NFT, a contract that means NFT, and I'm going to call it NFT mint contract. Then create a struct. What should we call this? Let's make it interactive. What should we call this token? So I want to create an NFT token. What should we call it? I can call it berry. Alright. Then as an ID and as a store. Sorry. It's supposed to be a key. ID. Then pass the name. Pass the URL. Passing description. So yeah, so not just that alone. So metadata, what kind of metadata do you want to give it? I think it's fine. So now, so let's have a function that is going to remit this in it, right? So NFT, that means you are creating it and transferring it to an address, right? So I'm gonna do let's new NFT equal to berry, right? New berry. So berry is going to have an ID. expression context. Yeah, it is. Passing name. Passing what else? URL, right? And description. URL vector. Then description. Description we use the reason why I'm using string, I'm not using U vectors of U8 is because let's say in the description someone wants to use an icon like an emoji, something like this. So yeah, you would want to use this, right? So if you want to use this and you use vectors can actually take it, but it's very much handled when you use strings instead of using vectors of U8. So what am I saying? So there are two types of strings. There is string of ASCII. So that guy only takes in characters that are available in your keyboard, not emojis like this. So I'm using the string so you can have provision to use that. So yeah, we're going to convert because we're going to be having a type here. So type error there. So we'll have to convert name from. We'll have to. Yep. Then this won't go still, so we just have to change this guy to AC. I think that's better for space storage. Yeah, it's not complaining anymore. As in, giving this expected. Oh, so change to yes, that is cool. Then for the string you have to pass in a URL, right? So you need to use from URL URL. That's all we need to pass in here. So string has to be a type of URL. Passing a string for the URL. So do URL string, then send something, calling valid input error, giving string expected. Okay, so let me convert it to then what is saying? Send local still contains the value. Yeah, I have to send it out. So yeah. Woo! Passed in the string. Okay. Yep. So you have to transfer what you've minted. Let me look at something. So So we just have to pass in address. So let's pass in the recipient. It works, and this is available by privilege. So this works. So you can easily create this NFT and mint it, and yes, I think this works very well. But then now, explaining the object-centric nature. If you pay attention, you notice that this is a model. Now this is an ID, or this is an address. Now I'm going to take you guys to the move.toml file. So from there I will explain what all this is. Right? Now, after doing that, I will also explain in the diagram. So this is your move.toml file. It's like the build file for your package. It contains the package name, object explained. I'm just explaining object here. Then when I want to run the smart contract, I'll now explain the assets, what has to do about assets. So now this is the name of the package. Now if you look down, you have your edition. You can actually change the edition you have into a lower one, or you leave it this way. This is the highest for the interim. There's the licensing. You can choose for MIT, whichever license you want to use. Then author, you can change it to your name. Now, dependency can be by Git, can be by an ID, can be by local. So here there's address, and you have now observe that the object address is pointing to OXO, which is object address of 0. Now there are also dev dependencies and the rest, but then let me use a diagram to explain that object system for the package. So this is how the package tree should look like in your mind. So you have your package. This is your package. Now you have this your package. Your package is, you now have your model. You now have inside your model, you now have the likes of struct and all. This is an object on its own. It's a layer above your model, and your model has every guy that is in terms of a constant, a function, a struct, of recent you have an enum, so it is in this manner. It is in this manner. That's why you see it is in this manner. So you have package model, you have constant, you have a function, you have a struct, you have enum, What else am I meeting? For the internet, this is what I can remember. So that's how the structure is. So in your similar JavaScript, you know almost everything is an object. So you can easily do dots, this and that, you get what you want to get. So that's why you see in the smart contract I wrote, at times, if you look at this now, okay, so this tree actually is a package on its own. The URL is a model. Now, if you look at this guy is a struct. Let's look at that. So if you understand the object's nature of how things works, you can really look at how it is. Here, it's almost the same way. All right, consider it the object such that it is in a way independent of itself and it has an ID to call to a particular structure or stuff. So let's look at this. So you see that you have packages, Sui framework, you have source. So the Sui houses this UMove model. This is a model. Look at it. You have the Sui framework, right? That's a package. Packages, there's a Sui framework, right? Then sources, this is your model. All right. Look at it. This is it. Just like how we have this. So what is supposed to be here is objects explain. Yeah, this is what is supposed to be here. This is the name of the package, and this is the name of the model. Then you have a struct, you have a function. So that's how all the object-centric nature behaves. But then, object-centric nature again, if you are looking at it in terms of chain, you understand that every token in the Sui network is an object. Your address is an object. What else? A struct in your smart contract is an object. Your package that houses every of your smart contracts, your model is an object. Your module is an object. So that's why you can easily from your package, using the package ID, can target a particular struct, can target a particular constant, can target a particular function because it has an object-centric model. I don't know if you understand the whole. Yeah, so that's the whole concept about it. Then the asset-centric nature about it is, for me, from the way I understand it, is whenever you create an asset in the Sui network, I think the asset-centric nature is pointing out to how the network handles assets when you're coding stuff on your SwiMove programming language. So you don't just create stuff and leave it on your smart contract. It has to be sent to an address. Unlike EVM, where you can actually just mint a coin and it can walk away and nothing will happen to your smart contract. So here now we've implemented a minting, a bearing structure, but then we cannot just leave this contract this way without pushing this asset that has been created to an address. It's either we'll push it out or we'll burn it. That's the asset-centric nature. So the Sui is centered around assets and objects. It will not execute, you cannot run it. Okay, what if you don't transfer it? Let's look at it practically. Let me know answer. So now we've created this. Let me comment out this line. Let's see what happens. I've saved and let me try to compile. So it's going to happen. So it's telling you this one can be suppressed with blah 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 blah, but then unused value. So that one is the one. This is the error now. Unused value without drop. So you need to add a drop to make sure that okay fine. But then this is an asset that is being created, and if giving it an attribute of storage, so you cannot have drop and store at the same time. We can test it and see if it works, but then it doesn't work that way. So you have to send out this asset. This is money. This is some level of. I don't know if you understand. So you can't leave it to the smart contract. Smart contract doesn't have that capacity of keeping assets. It has to be transferred somewhere. Or you can make it a shared asset. So you transfer it as a shared object. That's the only way. So if you make it a shared, everybody can access it and use it. So we did something of that sort when we were trying to create a DAO yesterday. But then we're trying to mint now. So since we're trying to mint simply means on chain that you're creating stuff, right? So minting, so you have to send it to whoever that is minting. So it will not then. But then if you don't want to transfer it, you can destruct. So you can come and say Berry. Yeah, so this instruct is burning. So let's look at this object delete. Let's analyze. So now, why I'm doing this, I'm trying to explain the concept of the asset-centric nature. For me, the way I understand is asset-centric is just the mannerism behind how, or the way Sui network or chain handles assets. They are, because of security, so you cannot create an asset and forget it in smart contracts. Either you transfer it or you burn it. Alright, and there are also other measures too they employ to handle assets and operations, such as treasure caps. Right, those treasure caps are like constraints that are placed to make sure that whoever that is trying to perform a particular implementation has the rights. Then also there is one-time witness, such that let's say you're trying to create a coin, so that will only run once, and it has to be run by the person that is executing or publishing that contract. But then this aesthetic nature is, you cannot just wake up one day and just how will I say it now, transfer a coin and leave it on the smart contract. It has to be moved somewhere. It's kind of, it's asset-centric, it's asset minded about how you use your token and stuff. You understand? So, and aside that, yes, so that's it. And so what I practically did here is I created this NFT and I burned it. It has been destroyed. I did not transfer it out. So since you don't want to transfer it, you can't keep it in the smart contract. You have to take it off. So, but then let's evaluate this delete. So this delete, what it does. Let's even read it. It deletes the object and its UID, and this is the only way to eliminate a UID. This exists to inform you of the object deletion when an object gets unpacked, and the programmer will have to do something with the UID and stuff, blah blah blah. So no process object deletion. Yeah, this is it. So let's see what this implement does. I don't know if I can delete this, but then it's not clicking. I should see. Delete implement. Fine. Oh, it's a native on Canvas, but then yeah. So that is what it does. But let's see if we can actually add an ability. Here you go on. Yes. I just showed it. I destructured it. I deleted the UID. Let's examine this UID and see the properties. Before it was telling us we should add drop. So if you add drop, there's a complaint. This complaint is saying invalid field type. The struct was declared with ability drop. So all field requires ability drop, and your ID doesn't have the ability drop. All field including name must have the ability drop. URL must have ability drop. Description must have, but UID doesn't have. Why I added drop? So that you can easily just create the token and leave it like that. But then, whenever you're creating an object, now this is the type between the object-centric nature and asset-centric nature. So it's like every object is an asset. Let me not say every asset is an object. So what makes it an object is the fact that you can give it a UID and it is storable, right? So now, if you add this drop, it complains. But then let's see how this guy is being defined. So this UID has stop. All right. Then yeah, that's practically it. So let's move on. So don't waste much of our time. We can achieve all that stuff. So I can come back again and explain some stuff. So, like to answer the question you just asked. So you say what? Say how did I bond it? This is how I bond it. So I did this. So yeah, so doing this is like saying, oh, we bond this guy off, so this guy is someone again and stuff. But then I don't want to create an access and throw it away. So transfer it, right? So everybody's fine, it's cool. Yeah. So let's publish this contract and let's now look at it from a Swiss scan or vision and see what makes it really this object or an asset and stuff. So it's just so published. So let's look through this. So I like copying this stuff because I feel this information are important. So I'll copy from here, I'll paste it in my text editor. So if I by mistake eventually delete this, I don't lose the data. So yep, I will just open this and create a new one. You can see my screen, right? Yeah, so first let's evaluate this. You have transaction digest, transaction data. This is sender, this is my address, and this is the gas. Gas is like bank charges. Yeah. So transaction kind, programmable transaction. Excuse me. So inputs, you have type, address, file. This is the address, and this is the command, publish. Yeah. This is signature. This is transaction effects. Transaction effect, what happened? So created an object, mutated an object, and the gas object, and this is gas cost summary. Storage cost, this is storage cost. Another thing, so this is for inquisitive minds that are here. So another thing you have to put in mind is for a good measure, such that you want to create a DApp that consumes a lot of storage on chain. Because the more code you write, the more logic you write, you demand more storage, right? Not necessarily more code, more smart contract, right? But then the more metadata, like for instance, more information that token house, it takes more storage on chain, and that increases your gas fee. Right? Though the gas fee on Sui network is very, very affordable, but then every dollar counts, every minute counts. So there's a better solution that cater for that, so you can utilize, can look up stuff like Warus. It's a cool guy for storing stuff. So yeah, so created objects will have account address, we have we also have mutated objects. And yeah, so these are the objects that were created. We have upgrade cap. Upgrade cap. This upgrade cap is when you want to upgrade the smart contract. Use this guy to upgrade the smart contract. But mind you, if you make some changes to your struct, probably the argument in your struct, argument I mean is stuff like this. Maybe you come down here and you now say, what should I put here now? Age. I say age 8. If you try to upgrade it, it will not work, alright, because you've added something, so you just have to publish again. Except you went on to maybe make some modification to your yes, let's say for instance you added another function here that can work, because the upgrade work based on the current structure of your smart contract. So if you're upgrading, probably you've added to the current structure, but if you alter the previous structure such as what I just did now, the upgrade is not going to work. So that's the use of your upgrade cap. Then mutated objects, then publish objects. So mutated object is the sender, this is the owner, the object type is con. So mutated objects. So in course of deploying or publishing this smart contract on the SWI network, so there has to be some objects splitting. So your SWI token is also an object, so you have to split it to pay for gas fee transaction. So that's why it's being mutated. That's why it's considered to be mutated. Then published object is the object which is the package that we just published. So see, you have all the objects you observe, they have an ID. So this is the object-centric nature that we're talking about. Right? Observe, you created an object, mutated an object. So I said earlier that your tokens are objects, right? Your tokens are objects. Then, of course, you see this object that is being mutated is a token, which is your SWI token. So you created an object. If you observe and I say an object on the SWI chain must have an ID. What makes an entity an object is the ability for it to be relatable based on a tag. So the tag here in SWI network is the ID, so the object that I have here. So if you observe, they are almost following the same pattern, and all of them have the same version. So you see the version is 434.362.666. So that's the version. You can look at the screen. See the version here. See the version here. The version, you see it at line 102. See the version at line 111. Then the last object, published object. So this last one is the housing. This is the bigger object, right? So the bigger object here is the package that we just created. The package which is the object explained. Not that this is a package. Now let me explain something. So whenever you see me come up and as this we move new, I'm creating a package. That package is going to house models, and those models are going to have constant and stuff, just as I explained here. But then this is an object. This is an object. The model is an object because you can always relate this model with the object ID of the package. We are going to see that now. Then, so these are the objects that object changes that happened on. Yep. So now let's browse. Let's look at this on chain. Let's look at this. Okay. Then look at my screen. So I'm going to explain the concepts now. So now for development purposes, so there are not different chains, but there are three environments. Now look at this. There are, for instance, the soldier has to become a soldier. There are processes, and there are different environments for those processes. There is a screening environment. There is a training ground environment, and there's a real world environment. Yeah. So the screening environment is very, very soft, not too serious. Those are the screen and select. Then there's a training ground environment. They really drill you. Then it's still also a selection points where some people will fall off and some people will be proceeded to where they will be, inaugurated as soldiers. So that's how it is here. So we have the main net, you have the test net and the dev net. You won't have down to the local net, right? So the main net is where the real deployment happens for the smart contract. The test net is more like a pre-main net, right? So it simulates almost every of the features. So it it's not like DevNet that the information you need persists for just one epoch. An epoch is 24 hours. So after one epoch, whatever that happens in your DevNet, then your local net is like a node, a simulation of a node of the Sui network running on your machine. So you run a server that simulates that node. That's a local net. So now, for what we just did, I published that to the testnet. So I'm switching environments, right? So that's what I'm currently doing. So as I see, I click here and I'll switch to testnet, right? So let me now look for the smart contract that we published. Oh, not that. Run the code. Yeah, so you can use swim move clients, then you add the move commands. That I'll show you that, but then I want to show you how you can actually test it from your scan and explain. So I don't want to really go too into coding, okay, but let me show you that. So you can easily do swim clients. So let me make this big. So yeah, this call. So you can call a move function from here, but then you have to specify the package ID and stuff. Get. So I can do that. I can say call. I'm using -h because I can't really clearly remember all stuff. So this is how it works. This is it. You can do swim, client, call. These are the options. Then you put the package ID, model ID, and the function. Yeah, so you can easily test it from a terminal here. So since we've deployed it, right? So we can put the package ID here, put the model ID. Not really like model ID, but then we target the model that is under this package. You don't go and call the model that is inside this package. Then you put the function and voila, that's what you get. That's how it works. But then I won't do that for the scope of this workshop. We just have to stick to what we have on the slide. So now, so if you observe, this is a package. This was telling you this is a package, and this is the ID of the package. Then let's check the block. If you have nothing, let's check the smart contract. Yeah, we'll have. Yeah, so there's an issue. So we have the main function, but there's no entry function. So now, for you to have the entry function is just like your ports that you attach to the endpoint of your API. So if you don't put a port, you cannot access. Yeah, so that's what an entry function is. So those we'll have to come back here and make this function an entry function. Right? Else somebody from the front end will not be able to interact with your smart contract. So we have to publish this again. So this we clients publish. Yep. So that should push it down now. Published, then take this. So so you cannot call the function now. So you see, you cannot call the function. So yeah, the first argument. Let me see what the first argument is. So we have name, URL, description, the recipient address. Name, URL, description, recipient address. So name, Goldman. Okay, name of the Goldman. URL. Description. This is URL. Okay, so this is description, right? Goldman. What do you say? Okay, good. See, specifying the type we have to pass in. Goldman token, right? Then the address. Let me take my address. Then the URL, let me look for something cool. What should I use? Let me go to that icon. And system is going to go off any minute from now. Okay, low battery. Okay, that's cool. Then let's just make sure that we mean something, then we can zip off. Then yeah, we'll do some installations for the guys and all kind of stuff. transaction applied, created this. So let's check what we've created. And see. Yep. Though our image is not nice, not sharp. Yep. And yep. So the image is pointing to this. We would have gotten the NFT is Goldman. Yeah, Goldman. So our image, I was thinking it's supposed to be very sharp. Okay, but it's not sharp. I don't know. Let's just be fine with this. So the owner is me. I minted it to myself, and what was in storage 0.000019684 sui, and what's that? Yeah. So we can actually mint it and attach a value of some sort of amount of sui to it if we want. Yeah, give some treasure cap, blah blah blah. Yeah, and mint it and yeah, make it tradable. Yeah, we can do that, but then not for this scope. So let's finish our slide. So yeah, you can see we've created an object. As you observing that it's telling you that this is an object, an NFT actually for that matter, and has an address, an object ID, an address, and this is an asset. This is an asset, so that's why you cannot keep it because it has store, so you cannot leave it within the chain. Right? So yeah. So back to the slide. So yeah. So what is blockchain? Yeah, blockchain is distributed ledger. Yeah, immutable, transparent record keeping and transactions stored across. So yeah, so it's a distributed ledger. How is the blockchain distributed ledger? Very simple. So let's have a PC, and this is a PC, right? Have another PC here, have another PC here, and have another. Okay, let's work with these three first. This is connected to this. This is connected to this, and connection is this way. What does it tell you? This tells you that whatever is in this system can be accessed by this guy and also can be accessed by this guy. So they share common information. But then this is a distributed system. So the blockchain is a distributed ledger. Now, it means that ledger is distributed across every PC on the chain. And a chain consists of nodes, and these nodes are comprised of physical hardware in the form of computers that are running computation for validation and stuff. Do you understand? And these nodes contain blocks. These blocks contain transactions. Do you understand? So in a block you can have like thousands of transactions if you want. So what makes it a blockchain is because the ledger that is here, let me get it means the ledger, this ledger is available here. So what makes it a real ledger? Because this information that is here is also available here, it's also available here. Alright? Now what makes it a blockchain is because, let's say for instance this is a node, right? You can now have something similar again here, have another one like that here. Pay attention. Then you have probably another one here. Now, out of all, above all of them are still connected. Yeah, see, everybody's still connected. So this is a blockchain now. So this ledger is available in this chain. Everybody can. So it means you have persistent information, the particular information persisted in every of the PC. That's a that's a lay way of explaining this thing. That's what makes it a distributed ledger. So that's why it is transparent. So you cannot have this information hidden from Mr. A and B. But then the street network is so sweet that there is a technology called seal. So seal can enable you to encrypt this file. So when this file is encrypted, you don't understand what it is. But then you see what it is. So it's considered to be the first of what we call decentralized secrets. So that's a very, very long term stuff we're going to touch. Right? But then there's no technological worry. So people worry about how do they manage the storage of big stuff to persist everywhere and still fast. Yeah, they can still do that. And they will not worry about, because the blockchain is not supposed to be deleted, right? But then you have to understand that it's a distributed ledger, not a distributed how do I say it now, file system, or like not a distributed, I don't know what to call it actually, but then it's a distributed ledger. That tells you that ledger simply means record, writings, transactions. So yeah, that's what it is. Not really. Yeah, so immutable transparent records, keeping and transaction stored. Oh, the record is there. Stored across the network. Of course, this is a network. Why is it a network? This and this are connected. That's a network. Yeah. So intro to move language. Yeah, code move just now. They created a smart contract that means an NFT. We've done the NFC and we run some command in CLI. Very cool. Basis of transaction, mint NFT and NFT send. Yeah, so we'll need to write a smart contract that sends NFT to another person, right? So we've mint, so we need to send the token, right? Does that work? Can actually write a smart contract that sends token. Yeah. So then quiz, yeah. So I'll pay attention to this quiz much later. Mini quiz. What's sweet objects model? How is it different from solid? Yeah, I explained that. And deploy. Yeah. Yeah. So I'm very much concerned on the. Yeah. So let's see how we can write a smart contract that. But then we can easily do that. So you can do that from a slush wallet actually. How many of us have an address in slush here? Have a slush wallet? Everybody have. Oh, that's nice. That's nice. So we can just look at the slush. So yeah, I would have loved to write it programmatically, but then what I just minted should be on my slush wallet. So if I check my slush wallet, I should see. It's not it. Let's see. Two four 2714. Okay, let's just update this guy. Transfer token. Recipient who will transferring it to. So we need to check if whether we want to know who is the sender, right? Sticks. Oh, we can find. Yeah, the next is see, it's going to be need to check if the okay. Speak up. Yeah, I'm writing for this specifically, but then I think you should be able to transfer any NFT you want using if you can specify the object ID. So yeah, so if you can, because obviously, yes, I think yes, you should be able to transfer any kind of NFT you want. So because there are a lot of like in your slush wallet, you can have a lot of NFT, right? Different kinds, so you can transfer it to any address. So once you can specify the object ID, terms of an address, you can easily transfer NFT. So what is going on my head right now? So yeah, you can transfer any NFT you want. So the way you do it, you just come here, you do this. This can be T. Then you come here, you say this T, right? Yeah. So this will now be this guy. That's how it works. So you pass this is generic types. So yeah, you pass it that way. So what we created, we did not create a coin. So let's say you want to create a coin. That's how you create a coin actually. So we just created a random NFT. So let's say you want to go for that one step and create a coin. So that's how creation of a coin. You need to pass the coin type, right? So the coin is not a tree. Let's say the coin is blueberry coin. So you do coin, put the type, which is blueberry. You can change to blueberry and stuff. So that's how it works. So, but for you guys are very new to Sui and stuff. For simplicity's sake, yes, let's just do it this way. So once I start, if the sender is person initiating this transaction is actually the sender. So yeah, if person is not the sender, we show some error, right? So come here. that's what we'll do. But I'm very curious about whenever this new move analyzer complains. So I really want to know why she's complaining. So yeah, so the parameter NFT still contains the value. Yes. So this guy still contains the value. So we have to transfer it. Right? So we've checked. Okay, fine. This guy is the owner of this asset. So let's transfer the assets to. So let's deploy again. Yeah. So let's take this guy up. Let's interact with this one. Yep. Very name, URL description. I need a better icon. I don't want something now. Natural, we're supposed to use cross. Brighter now. Cool. And let's transfer this guy. So we have to take, let's look at the parameters. So sender, recipients, and NFT. Sender, recipient, and NFT, and yeah. Recipients. Okay, I need one of your address. This guy. You can send yours. Just be faster than him. You're not on the group chat. Why? You'll be added at the end of today's lecture. Sent it. He's here for the bag. You won't tag me, man. Okay, it's not sent. Check it. Check your address on Swiss. Let me check the address of this on Swiss scan again. And you see that the owner should have changed to you. has switched. So we check now. Don't know what happened earlier. So check the owner's address has changed. It's no more my own address. So I think the owner right now. So check copy your address this way and head on to see scan and then switch to testnet. You see it? Cool. I wish you can test this. So I don't just kidding. It worked so successfully done something. So yep. So yeah, so that's it. So successfully completed the iterated code lab or workshop. So successfully we're done. Okay, so we've not mentioned interval installation. We've talked about entry function struct. We've talked about how you can view your model in SysScan. Yeah, yeah. So we've summarized everything in this workshop, and you guys already noticed it. So we've done the practical stuff, which is the basic mint and send. So yeah, voila. I think we should close the curtain here, and yeah. So next workshop we do something more better.